Well, good morning to the 1, 2, 3, 4, 5, 6, 7 of you. How are you this morning? Shoot me a comment. Ladies and gentlemen, because Lauren is the only male that we have with us so far. Shoot me a comment on how you're doing this morning. Hey, I got a chat. That's good. Oh, that must be new from, oh, that's a good feature. They've updated Zoom yesterday, and they'll show the chat without me clicking on it. Pretty well. Tired. I'm good. Okay. Good and tired. And Jenna, I think you might have your hand on the slash bar and chatting to me because you're sending me a big long chat with a bunch of slashes.
It's not showing me anything.
Maybe I'm doing that. Oh, I was doing that. I was responding to you with a bunch of slashes. Okay. Here, I'll send you a chat. I'll show you what it was doing. Oh, it's still doing it. Well, what do I have? Oh, it's up here. Okay, it's on. I got two keyboards going, and my cord was on the one. Here's you another chat, Jenna. There you go.
Thank you.
Yeah. Doing good. How are you? Well, I'm fine. I had a good joke the other day. I told it is on a Wednesday night Zoom Bible study. So it went like this. What group of people in the Bible do you know had to be good gymnasts? And the answer was the Philippians. I was pretty proud. I didn't get a thumbs up. I didn't get a hand clap. I didn't get anything out of that. I mean, nothing. Not one reaction whatsoever. That's a shame. Well, somebody tell me when your final is.
Monday at 8 a.m.
Okay, Monday at 8 a.m. I don't really have anything else to say. Oh, I do have a couple things. Number one, if you haven't done it yet, don't forget to go on Moodle and respond to how you want your grade, whether you want a letter grade, a withdrawal, or a pass-fail option. If you choose withdraw or pass-fail, make sure you talk to a Shawnee College advisor first. And that needs to be done. I put a deadline of the 14th on it. Technically, it's the 15th. I have to know. If I don't hear anything from you, then I'll assume that you want a letter grade. And also on Moodle now, there's an evaluation for the class. So you can go in there and click a link. It's on the right-hand side of your dashboard. And I won't be able to see those till after the semester, the results of those. I'm trying to remember, I looked at the evaluation, just be honest on it, but if there's a place for comments, that's what's most helpful, because like sometimes on those evaluations it'll be like, teacher had knowledge of subject matter, and you can grade them like 1, 2, 3, 4, or 5. Well, if I get 4.1 on that, what does that really mean? It doesn't really tell me a whole bunch. But if there's a place for comments, hey, Mr. Black, I liked this about the class. It helped me, blah, blah, blah. Or, hey, Mr. Black, I thought if you would have done this differently, it might have been helpful, blah, blah, blah. Those are the comments that are really helpful. And so things I can consider and chew on to maybe make changes for subsequent semesters. So anyway, appreciate you going on there and doing those evaluations. It won't take very long. We were in the middle of the test over chapters 5 and 6 last time. We had been reviewing some probability stuff, and so I wanted to continue on that journey here. And the next problem we're going to look at off of that test is the chapter or problem number 11. So if you've got your test out and handy, you can look at that next. If you look at number 11, we change gears there. The church has 8 bells in its bell tower. Before each church service, 5 bells are rung in sequence. No bell is rung more than once. And here's the key: how many sequences are there? So we're changing gears here in the sense that we're not asking what's the probability, we're asking how many. It's a how many question. So I'm looking for something and I'll be right with you. I was looking if your book had summarized guidelines for counting anywhere, and I don't think they had. So this is something you're going to have to know on your own, but let's review the way that we thought when we got a how many question back in the day. So we ask ourselves 2 questions. First, we ask ourselves if repetition was allowed. I'll put a question mark. And if repetition was allowed, if the answer to that was yes, then we drew blanks. We filled in the number of ways each blank could occur, and we multiplied. If the answer to that was no, then we ask a second question. Does order matter? And if the answer to that was yes, we used a permutation. And if the answer to that was no, we used a combination. Okay, so let's look at a few problems that ask how many, and 11 was one of those. So let's go back and look at 11 and see if repetition is allowed. I don't remember the problem, so I'm going to reread it. The church has 8 bells in its bell tower. Before each church service, 5 bells are rung in sequence. No bell is rung more than once. So repetition is not allowed. Now, so I'm going to have to ask, does order matter? And the question here is, how many sequences are there? How many sequences of the bells is insinuating how many different orders of the bells are possible. So in this problem, order did matter. So we needed a permutation of 8 things, 5 at a time. That means we've got to remember where to find a permutation on the calculator. Or, this is a good time to mention this and to practice it one time. Or if we don't remember I keep saying that all of our functions for the calculator are in the catalog menu. So if I wanted an 8 permutation 5 and I didn't remember where permutation was, I could punch in 8. The catalog is the second function of the 0 key. And here are all the functions of the calculator, so I could just scroll down. It's going to take me a while to get to a permutation, but eventually I should get there. By the way, there's a way to quicken this up. You can punch in the letter P and then it'll take you to permutation, but I just never do that. I just always scroll. LMNOP. Well, it wasn't under P. I wonder if it's under NPR, and I hope I don't make a liar out of myself here. Let's look under N. Aha! Wait a minute. There's NCR. You see that? LMNO. There's NPR right there. So it's in the catalog if you can't find it anywhere else. So you could pull up the function, then punch in your 5. So the answer to that problem is 6,720. By the way, if you do remember where that function is at, it's actually in the math menu. 8, math, go over to probability, and NPR is number 2. So that's the fast way to find it. But if you just get on your test and you need some function and you just can't remember where it's at, go to your catalog. You can find it there. Okay. Now, the next problemo that I had chosen for us to look at is number 12. It's going to be another how many question. You're taking a multiple choice test that has 11 questions. Each of the questions has 5 choices with 1 correct choice per question. If you select one of these options per question and leave nothing blank, in how many ways can you answer the questions? So another how many. Now that was a lot of information, a little bit too much for me to absorb at one time. So let's break it down into parts. So I need to ask first, is repetition allowed? So I'm going to reread this problem and see if I can figure out if repetition is allowed. So what do I have here? I've got a multiple choice test. I've got 11 questions. Each question has 5 choices with 1 correct choice per question. Okay, so I got a multiple choice test and each question has 5 choices. So like A, B, C, D, and E. So is repetition allowed? Well, the answer would have to be yes. I'm going to have to repeat my answers somewhere on that test because I've got 11 questions and only 5 choices for each question. So by the 6th question, I will have repeated something. So yes, repetition is allowed, so that means we're going to draw blanks. Now, how many blanks am I going to draw? So I'm either going to draw a blank for each question or I'm going to draw a blank for each choice. Well, I'm going to draw a blank for each question because each question will then have 5 choices. So on this problem, we could have thought to ourselves, I'm drawing 11 blanks. Each one of those blanks could occur 5 different ways because I have 5 choices for each question. So 5 here, 5 here, 5 here, 5 all the way across the board. So this is going to end up being 5 to the 11th power. And 5 housetop 11 is this number. 48,828,125 different ways that test could be filled out. Okay, let's go to number 13. From 8 names on a ballot, a committee of 5 will be selected to attend a political national convention. How many different committees are possible? Okay, is repetition allowed? Well, what am I going to do? I'm forming a committee of 5 from 8 people. Well, we're not going to let one person serve 2 slots on the committee or all the slots on the committee. So repetition's not allowed. Now, does order matter? If you get confused on whether order matters or not, remember I told you just list out a possibility. For example, let's say one of my committees ended up being Rebecca, Jenna, Mackenzie, Grayson, and Lauren. And then switch any two of those. Say we picked them in this order: Jenna, Rebecca, Mackenzie, Grayson, and Lauren. And ask, is that the same result or not? Well, when you're talking about a committee, it doesn't matter what order we pick the committee in. It doesn't matter whether I pick Rebecca then Jenna or Jenna then Rebecca. It's the same committee either way, so order doesn't matter. So therefore here we need a combination. We're choosing from 8 and we're choosing 5. And an 8 combination 5 is 56. 56 different committees. So you're likely to see some how many questions on your final. And when you see that, you automatically go to, is repetition allowed? Does order matter? And then you're going to be looking at one of those 3 strategies, most likely. Okay, dokes. Okay, let's look next at numbers 15 and 16 on this test. Okay, number 15 says, in a recent survey, 70% of the community favored building a health center in the neighborhood. If 14 citizens are chosen, find the probability that exactly 6 of them favor building the building of the health center. Now, when you see this exactly, a lot of times those problems ended up being binomial probability problems. Do you remember that binomial probability meant 2 possible outcomes, success or failure? So I'm going to look at this problem and say, are there only 2 possible outcomes for any trial? Okay, so 70% of the community favored building a health center in the neighborhood. Well, if I ask you, are there only 2 possible outcomes? When I ask you, do you favor building a health center in the neighborhood? And the answer is yes. You either favor it or you don't. And when we had binomial probabilities, you remember we either used binom PDF, and then we put in N, then P, then R, or we used binom CDF, N, then P, then R. If you were looking for exactly the probability of exactly one amount, then that was a binom PDF. If you were looking for a total up to a certain number, then we used binom CDF. In other words, we did it cumulative up to the number. Okay, now this problem says, find the probability that exactly 6 of them favored the building of the health center. So this is a binom PDF problem. So binom PDF, what's my N? What's my number of trials? Well, if 14 citizens are chosen, so that's my total number of people, 14, comma. P was the probability of success on any trial. So if I ask you, what's the probability you be in favor? Well, it said 70% of the community favored a health center. That's 0.70, comma. And then my number of successes is the R. So in this case, that's 6. Okay, so the binom PDF and the binom CDF, think about it. The binomial was a type of distribution, just like the normal curve was a type of distribution. So it's in the distribution menu. It's the second function of the bars key. Second, distribution. Binom PDF on my calculator is letter A. 14, comma, 0.7 or 0.70, comma, 6. The answer to this problem was 0.0232. Now let's compare that to number 16. A recent survey found that 70% of all adults over 50 wear sunglasses for driving. In a random sample of 10 adults over 50, what is the probability that 7 or less wear sunglasses? Okay, so this time, if we ask if it's a binomial probability, well, yes, it is, because either they wear sunglasses when driving or they don't. Okay. So we do have a binomial probability. What's the question here? What is the probability that 7 or less wear sunglasses? So we're not asking what's the probability that 7 wear sunglasses. 7 or less means 7 or 6 or 5 or 4 or 3 or 2 or 0. So what I'm getting at here is this was a binom CDF problem. I want to accumulate all the way up to 7. Okay, my N is 10. My P here is 0.7 again. And I want to add all the way up through 7. That'd be a binom 10.77. And binom CDF is letter B. 10.77 is 0.6172. Okay, give me some reaction to those 5 problems that we just looked at. Okay, I got reaction from everyone except Rebecca. Didn't get anything from Rebecca. Okay. All right. So don't forget that the problems you need to make sure you know how to do off of that test are 1 through 7, 9 through 13, 15, and 16. You should have that written down from last time, but just a little reminder there. All right, that brings us to the test over chapters 7 and 9. And I told you that from this test, you want to make sure you know how to do problems 1 through 9. So that was the entire test. Okay, so let's see what we've picked out to look at here. A large part of this test was the normal curve. And then we also had confidence intervals on this test. So we want to be really good at both of those. So let's take a look at number 2 first of all together. Find the area under the standard normal curve to the right of z equals negative 1.25. So a couple of things to remind you of with the normal curve. If you're looking for area, then you have a norm CDF problem. And we put left endpoint and then right endpoint. If you're looking for a z-score, oops, then you have an inverse norm problem. And we're going to have to put in left tail area to get that z-score. I encouraged you on all of these problemos to draw you a curve and put on there what you're looking for. Okay, we want the area to the right of negative 1.25. Negative 1.25 is going to be to the left of 0. And to the right, which means we would shade over here. All right, so let's get some of you involved. So we're going to go to Mackenzie and Grayson. Is this norm CDF or inverse norm? And so you tell me which one of those it is and then what to punch in on my calculator.
I think it's norm CDF and use the negative 1.5 for the left endpoint, and then the right endpoint is 1E99.
That is exactly right. I cannot improve upon what she said. It's norm CDF. She said the left endpoint is negative 1.25, and we don't have a right endpoint. So that's when we're going to pull out this 1E99 business. The normal curve is a type of distribution, so the norm CDF is in the distribution menu. Number 2. Class, the answer that we should have gotten on number 2 on this test was 0.8944. Okay, the next problem I want to look at, and this was commonly missed on this test, as it always seems to be, is number 4, which said to find z sub 0.20. Well, now you probably know why I wanted you to be able to find this, because how many of our formulas, once we got to the rest of the class, did you see z sub something? We saw z sub alpha over 2 a lot. So remember, when you see z sub something, that means this area is going in the right tail. From a picture perspective, I would put 0.20 in the right tail and look for the z-score that goes with it. Okay, I'm getting chats. Let's look at chats, David. Lauren, I got you, Lauren. Gotcha. Rebecca, I see here. Thank you for the update there. So, Lauren, you're back now, though, right?
Yeah, I'm back.
Okay. Let's put you with Jenna and tell me what I'm going to enter on my calculator this time.
You're gonna do inverse norm 1 minus 0.20
And why are you 1 minusing?
because you're looking for a right tail area and inverse norm does left tail area.
It's perfectly said, class. Now, a lot of you on this test did inverse norm 0.20, but she just gave you a perfect explanation as to why it's not 0.20. Lauren gave you a thumbs up there, Jenna. So inverse norm 1 minus 0.2 is 0.8416 is the z-score. Ta-da! How many of those do you want on your final? It looks like these papers are about all used up. So maybe I should get some new paper out. Oh, hey, my trash can's getting pretty full. Okay, well, the next problemo I had picked out was number 6. A new phone system was installed last year to help reduce the expense of personal calls that were being made by employees. Before the new system was installed, the amount being spent on personal calls followed a normal distribution with an average of $700 per month and a standard deviation of $50 per month. Refer to such expenses as PCEs, personal call expenses. Using a distribution above, what is the probability that a randomly selected month had a PCE between $575 and $790? Okay. This is probably getting to be an outdated problem because it's probably foreign to all of your way of thinking that a phone call would cost money. I mean, you pay for a plan, and then you usually, most of those plans, you get unlimited calls. But back in the day, if every time you called long distance out of your own little area, you got charged a fee, and it could get quite expensive. So there might still be some plans out there like that, especially for businesses, but I don't know. Well, anyway, it says we had a normal distribution with a mean of 700. So let's go ahead and draw our curve here. And a standard deviation of 50. And what was it I wanted to know? Is what is the probability that a randomly selected month had a PCE between 575 and 790? Okay, 575 is back here somewhere. 790 is out here somewhere. And we said over and over and over again that probability or proportion or percentage all meant area as it applied to the normal curve. So we want to know the area between those two values. Okay. So we had to convert 575 and 790 to z-scores. I mean, by now, we should probably know that z is data value minus mean over standard deviation. So for 575, that would be 575 minus the mean of 700 over 50. And if I take 575 minus 700 over 50, that'd be negative 125 over 50. If I divide both those by 5, that would be negative 25 over, I think it's going to be negative 2.5. Let's see, 575 minus 700 is that stupid number. Divided by 50 is negative 2.5 for your z-score over here. We'll do the same thing with 790. So take 790 minus 700 over 50. That's going to be 90 over 50, which is 9/5, which is 1 4/5, which is 1.8. You're faster than your calculator. You just don't believe it. Some of you. But let's verify just to be sure. And there it is. 1.8. So really, that means I want the area under the standard normal curve between negative 2.5 and 1.8. Now we've got a norm CDF problem. My left endpoint is negative 2.5 and my right endpoint is 1.8. Second distribution norm CDF. Negative 2.5, comma, 1.8. Boom, shakalaka. How about 9.9579? 0.9579 is the probability that the personal call expenses for the employees is between $575 and $790. Okay, so do we have any questions about normal curve problems before I move on? Okay. Let's see, and double checking my notes here. That's what I thought. Okay, and then you had 3 confidence intervals that you were asked to construct on this test. So, I want to refer you to a sheet that I gave you to help you review for the chapters 10 and 11 test. You say, this was chapter 9 stuff, Mr. Black. I know it. I know. But do you remember this sheet? This was to help us to determine which test or confidence interval to use. Well, the only confidence intervals we had on the test for chapters 10 and 11 were those ones between the difference between 2 means or the difference between 2 proportions. But I could still use this sheet for any other confidence interval that I had. So if you get a problem that asks you for a confidence interval, you could still think in this way. Are there 1 or 2 samples? If there are 1, go to this left-hand column. Instead of, are we testing about, you could ask, are we constructing about? What confidence interval do we want? What are we constructing about? A confidence interval about the mean, the proportion, or the standard deviation? If it's about the mean, we'll use we wouldn't use a t-test to do a confidence interval. We would use a t-interval. If it's about the proportion, we wouldn't use a 1 prop z test. If we're doing a confidence interval, we would use a 1 prop z interval. And if we're constructing about the standard deviation or the variance, then we wouldn't use a chi-squared test. We would use the chi-squared interval. Okay? Now, this one, your calculator will not do. It doesn't have a chi-squared interval built into it, so you're going to have to use the formulas. Well, where do I find that, Mr. Black? Well, you can find all the formulas for these confidence intervals at the end of chapter 9. Okay, so make yourself a note as you're studying, reworking problems, and getting ready for this test. If you're asked to do a confidence interval about the variance or the standard deviation, here's the chapter 9 review. On the next page, there's that green section again. And right above that, here's all your formulas for the chapter. And here's your formula for the confidence interval, the lower and upper bound about the variance. So I'm looking on page 470 here. Or again, if you get on your test and you forget where something's at, well, go to your index. Look up confidence intervals. Definition of, for the difference between two populations, about the difference between two means. Let's see what it says here. For population mean, you could go to those pages. For population proportion, you can go to those pages. For population standard deviation, we should be able to find these formulas somewhere around page 457 to 459. And lo and behold, if you go to page 458, there they are. So one of the things you need to do, and I mentioned this the other day, but as you're preparing for this final, you're also preparing to see how you can use your book as an aid. Because if you don't do any preparation and just show up with your book, that your book's not going to do you much good. You got to be able to, you got to know where to find stuff in your book. That's what I'm getting at. And you're not going to have time to sit there and thumb through every page to find something. So you got to be able to find what you're looking for. Okay. So let's practice problems 8, 9, and 10. Robert wishes to estimate the mean number of miles that his Buick Rendezvous can be driven on a full tank of gas. He fills, I don't know why it says us, he fills us his car. He fills his car with regular unleaded gasoline from the same gas station 10 times. He records the number of miles that he drives until his low tank indicator light comes on. Well, that's nice. Indicator. I'm going to claim innocence on that because this test, I used a test generator to do, and so the generator roached it up. But anyway, he obtains the data below. Now let's go to part B. Construct a 90% confidence interval for the mean number of miles driven on a full tank of gas. Okay, so if I was thinking in terms of this chart here, are there one or two samples here? There's one. Okay. What am I constructing about? It says construct a 90% confidence interval for the mean number of miles driven. And if I'm constructing about the mean, I'm going to use a t interval. So all I would need to do here on my final is enter my data and then do a t interval. Okay, let's do that. Once you get your data entered, give me a thumbs up. Let me rephrase that. After you get your data entered and I get my data entered, after both of those things happen, give me a thumbs up. Okay, so one thing I'm encouraging you to do is to always go back and double check all your entries. Okay, mine look good. So I've got mine entered. Mackenzie, Lauren, Jenna, Savannah, Rebecca. Grayson. All right, go ahead and construct the confidence interval then that we're looking for. So hopefully you went stat and test. That's where all our hypothesis tests and confidence intervals are. It's number 8 that you're looking for, a T interval. We don't have stats to give the calculator, but we do have data. My data is in list 1. And we wanted 90% confidence. So calculate. So you're looking at 356.05 and 405.29. Okay, Mr. Black, we didn't use our formula. That's right. On this test, I told you to use your formula, but on the final, I told you you can use your calculator to do anything that it will do. Okay, so this is fine. You don't have to show me the formula. Now, I didn't mention part A here, but I could ask you to do a normal probability plot and interpret it on your test. So let's pretend like probably on this problem on the test, I'd only ask you for part B. But let's say on a different part of the test, I gave you this set of data and I said, construct and interpret a normal probability plot. Okay, so this is a type of graph, obviously. So to get it, we have to go to stat plot. That's where all our graphs are. Turn plot 1 on. And the normal probability plot was this last icon. And then like all our other graphs, if we just zoom 9, sorry, I've got a trig function on there as well. Mr. Black, that's pretty. Yeah, it kind of is. Trig functions are pretty when you graph them. Let me clear that off. So you guys don't have to mess with the pre-calculus. You can only mess with stats. Okay, so there's our normal probability plot. And remember, the interpretation is if it's approximately linear, then we can say that this data comes from a normal population. And here it is. So there's 2 birds with 1 stone, normal probability plot and a confidence interval. Okay, let's go next to number 9. Well, let me stop. Are there any questions about number 8? Give me something. Everybody good with number 8? Okay, number 9 says a student randomly selects 10 paperbacks at a store. The mean price is $8.75 with a standard deviation of $1.50. Construct a 95% confidence interval for the population standard deviation, sigma. Assume the data are normally distributed. Okay, so it's either a confidence interval or a hypothesis test. I'm going to go through this line of thinking here. Are there 1 or 2 samples? There's 1. Selected 10 paperbacks. What am I constructing about? Constructed 95% confidence interval for the population standard deviation. So I need the chi-squared interval. Okay, so let's set that up. Mr. Black, I don't remember how to do a chi-squared interval. That's okay. The formula is going to tell you how to do it. All we got to do is find the formula. And if I look back at page 470, like I told you, here's your green section. Confidence interval for sigma squared, that's the variance. Here's your lower bound. Here's your upper bound. I'm just going to copy the formulas down and figure out those values and plug them in. So what does that say? N minus 1 times s squared chi-squared alpha over 2 for the lower bound. For the upper bound, n minus 1 times s squared over chi-squared 1 minus alpha over 2. Now listen, class, at this point, if we don't know what n and s are, then come on. What have we been doing for 4 months? Seriously, n is the sample size. We had 10 paperbacks. So n minus 1 is going to be 9. And I was taken back on this test that several people didn't understand S. What is S? What is sigma? S is the population. I'm sorry, I said that wrong. It's the sample standard deviation. Sigma is the population standard deviation. So S is tied to the sample. Okay, our sample had 10 paperbacks. The mean price was that, and the standard deviation was $1.50. So our sample standard deviation was $1.50, and I got a square of that. Now that's the same numerator for both the lower and the upper bounds. Okay, now let's think about alpha over 2. Alpha is 1 minus 0.95, or 0.05. Alpha over 2 is 0.05 over 2, or 0.025. So chi-squared alpha over 2 is chi-squared 0.025. Chi-squared 1 minus alpha over 2 is chi-squared 1 minus 0.025, which is 0.975. You guys go look up these two numbers in your chart. You're going to use 9 degrees of freedom because our sample size was 10. And I'll ask somebody for those two values in just a moment. Okay, Grayson and Savannah, what's the number for chi-squared 0.025?
19.023.
Grayson, do you agree with that?
Yes.
Okay. Jenna and, well, Rebecca's having a little bit of internet problems. Jenna and Lauren, what's the number for chi-squared 0.975?
2.700.
Okay, they both said 2.700. Okay, so we'll plug those in there and we'll crunch numbers. 9 times 1.5 squared is that stupid number. Divided by 19.023 is this stupid number, 1.065. Nine times 1.5 squared is still that stupid number, divided by 2.700 is this stupid number. 7.5. And somebody right now is saying, Mr. Black, that's what I put on my test and you took a point off. How come? Anybody know why?
It's not squared.
That's right. This is the confidence interval about the variance. Remember, the variance is sigma squared. So if it would ask for the variance, this would have been my answer. But if it asked for the confidence interval about the standard deviation, then I need to square root both of those. So the actual answer was 1.032 for the lower bound. And if I square root 7.5, 2.739 for the upper bound. Boom, shakalaka, that's the one we're looking for. So be careful of that. Look and see whether you're asked for the confidence interval about the variance or the standard deviation. Okay, now that problem was very commonly missed on that test. So if you got a question somewhere or something you didn't understand, now's the time to shoot me a comment or question. So I pause here. So listen, this is what I'm trying to tell you though. If you get that question on your test and you say, I don't remember how to do that, you don't have to remember how to do it. What you got to remember how to do is find these formulas. The formulas will tell you what to do. Now, you do have to know what the symbols in the formulas mean. So if you don't know that, then you got more studying to do on that stuff. But I mean, seriously, by now you should know what N and S are. And you should know how to use the chi-square distribution. You should know that alpha is 1 minus the confidence level. So, I mean, if you've been doing homework at all and studying for test at all, you know what these symbols mean. So if you get the formula, then you can get to where you need to go. Okay, let's go to number 10. A survey of 600 non-fatal accidents showed that 267 involved uninsured drivers. Construct a 99% confidence interval for the proportion of fatal accidents that involved uninsured drivers. Now listen, on the final, I'm not going to worry about this last part too much. Show that the conditions for constructing such a confidence interval are satisfied. I'll probably just allow you to assume that they're satisfied and ask you to construct the interval. Okay, so again, how many samples do I have? 1. What are we constructing about? The proportion. Well, when we have 1 sample and we're going about the proportion, I'm going to need a 1 prop z interval. Okay, so let's go find a 1 prop z interval on our calculator. Stat, test. Don't want the 1 prop z test, we want the 1 prop z interval, and that's letter A on mine. And all I got to do is punch in my data. X and N, we had what? 267 involved uninsured drivers out of 600 total. 267 for X, 600 for N. We want 99% confidence. In class, it doesn't get much easier than that, does it? How about 0.3927 and 0.4973? Okay, any thoughts or feelings about the test from chapter 7 and 9? I'm getting thumbs ups. Okay, so you want to make sure you're up to speed on that entire test. One, two, three, four, 5, and 6 are up here. Okay. And that brings us to the last test that we had. All right, I'm getting situated here. Check my time, 9:03. Yeah, we're probably good for a break here. And then we'll start in on this last test that we just had. So break it, and I'll see you in about 5 minutes. And we'll take a look at that. Well, I don't know if you're on the other end or not, class. I have no way of knowing. So you're going to have to let me know if you're on the other end or not so that I will have a way of knowing. Okay, thumbs ups, chats. You're here. Okay. Some asked me if I could somehow get them copies of the test, the first two tests, clear copies, and the answer to that question is I'm not sure. So today, and if I can run those down without spending 6 hours doing it, then yeah, I'll send those to you. And if I can't, then I won't. So, but I'll try, and I'll let you know one way or another to the person who emailed me that request. And here come the chats. I know what they're gonna say. Where'd the chat go? There it is. They're still in our email as long as they didn't delete them. Might have been printed off. Yes, but somebody chatted here. They are still in our email. That's true, but this person was talking about the test that we took face to face. So they were wanting to practice, and they thought it'd be easier to practice on blank test than on their old test where they already had stuff written on it. So I get that. I hear you. I'm picking up what you're putting down. Picking up this coffee and taking a drink. It's pretty good. Doggone it. Let's have a talk. How you guys feeling about the final? What kind of score are you predicting for yourself? Are you scared? Are you nervous? Where you at? Talk to me.
I'm feeling pretty good about it.
Okay. I'm a little nervous.
That was a choice.
Okay. Okay, let's go back to the person who said I'm feeling a little nervous. Who was that?
It was me.
Okay. What's giving you pause, Jenna?
I think just the fact that it's cumulative kind of freaks me out.
Okay.
I have to remember everything, and it's hard for me sometimes.
Okay, gotcha. Kaylee, you were speaking.
I was nervous until it was like told us it was multiple choice.
So why does that make you not nervous?
I just find like multiple choice tests are like easier for me to complete. I don't short answer and like basically where you just go through the whole thing and there's no options. Like that just stresses me out for some reason.
And then I think I cut somebody else off that was talking. Who else was talking? Nobody. Okay. This one really has nothing to do with getting you ready for the final. You're just doing this for me because you're going to pay do Mr. Black a favor here. What, if anything, can we do in my summer classes to make this Zoom situation? What's good about what we've been doing? What could we do to make it better? Give me some feedback there. Grayson, you can go first.
I think it's all right, honestly. I just like having my camera off.
Okay, Savannah?
I think it's been going pretty well. I mean, it's like the same as class to me, but I liked it.
Okay, that's about the best thing I can hear. Lauren, Jenna, Rebecca, Kaylee, Mackenzie, share a concern. Somebody's probably got a concern. Somebody share a concern.
Can you hear me? Hello?
I can hear you. Yes, sir.
Oh, okay. I think that like this Zoom has gone good compared to other classes I have, where I feel like teachers, I just feel like, you know, how do I put this? Your class has been the most normal since we left. So I feel like you don't really need to change anything in my opinion.
Okay. Well, I appreciate that comment. That's what I've tried to do. I've tried to keep it normal, as normal as I can. And so you guys, for the most part, have attended all the meetings, and that keeps it normal. So and I have had some students who haven't attended the meetings, but it's obvious they're watching the videos, and some have done okay with that. But I think for most students, there's value in attending the meetings and having what's the word, exchange between teacher and student. I do think some students have gained value from being able to look at a video, though, stop it, go back, look at it again. So I guess the optimal would be if students like you attended the meetings and then still had the videos as a resource. But thank you for your feedback on that. I appreciate that. And continue to try to look for ways to improve it as much as we can, but try to keep it as much as normal class as possible too. So yeah. If you get any thoughts on that, shoot me an email or something. All right. So the last test, generally speaking, for most of you, was either pretty good or really bad, one of the two. So I thought we'd just work it start to finish. And most of the tests we've had this semester, we've had some like mid to high 90 scores for at least, you know, a student or two. And we didn't see that on this test. The high score before I curved them was 89, which is really good score. But we've all got some improvement we can do here in chapters 10 and 11. So let's just work through it. Let's just start, go one problem at a time. I thought about cutting off here and just doing this next time, but I'm not sure an hour is going to give us the time that we need to get through all these the way we want to get through them. Okay. So number one, off of the last test, says the commute time in minutes of 20 randomly selected adult males are listed below. Test the claim that the standard deviation is less than 2.5. Use alpha equals 0.05. Assume the population is normally distributed. Tell which test you are using. Show all 5 steps of the classical approach. Okay, so if this is your final, it'd probably say something like this. Test the claim that the standard deviation is less than 2.5. It may not tell you which method to use, or it might say give the p-value, or it might say give the critical value. So it may not give you an indication about which one to use, but by what it asks for, it may require you to use one or the other. So we're going to still need to be familiar with both methods. So in this test, we just walk through the 5 steps. If you can walk through the 5 steps, then you can do any hypothesis test. Okay, so let's get to the proper test. Again, thinking through our list here. So, are there 1 or 2 samples? Okay, well, there's only 1 sample on this problem, so we're over here. And what are we testing about? The problem says to test the claim that the standard deviation is less than 2.5. So we're testing about sigma. So this is the chi-squared test. And again, this is the one our calculator won't do. So this sheet's really helpful. Again, what's nice, this chi-squared test, our calculator won't do, and it wouldn't do the chi-squared interval either. So those are consistent. Now remember, there is a chi-squared test our calculator will do. That chi-squared test on our calculator is the one for independence, and it would also do the chi-squared goodness of fit test. It's not this test. Okay, so that means we're going to have to look up a formula for the test value. Okay, so what are we going to do here? We're testing to see if the standard deviation is less than 2.5. So we're going to assume that the standard deviation is equal to 2.5. Step 1. Step 2, sigma is equal to 0.05. Step 3, we got to have a test value. It's a chi-squared test. So we're going to have a chi-squared naught for our test value. And I got to be able to find that formula when I need it in my textbook somewhere. Okay, so where am I going to find it? Well, this is where you got to know that our hypothesis test started in chapter 10. That chapter 10 did all the 1 sample ones. Chapter 11 did all the 2 sample ones. Okay, so let me show you something else. If you know, I keep referring to that handout that I gave you, but if you know your 1 sample instead of 2, then 10.5 is a section that we didn't do, but it's got a chart in here that'll point you to the right test. Okay, so if you're 1 sample and you're testing about the P, well, it doesn't call it the 1 prop Z test here is the problem. Okay, so maybe that doesn't help. But anyway, over here, it's going to give us our formula for the chi-squared test value. Or, again, you can find that in your chapter review. Right above your green box, you'll find your formulas. And here's the formula for the test value for the chi-squared naught. Okay, so it's n minus 1 times s squared over sigma naught squared. Lost my pen. Oh well, let me grab this one. Okay, now, some of you didn't do a good job plugging into this formula. Okay, so n minus 1, that's our sample size minus 1. How many values did we have in our sample? Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 of them. 20 values. I just found my pen stuck in these papers. S squared, you got to know what S means. It's the sample standard deviation. So I got to find the standard deviation of these 20 values. Let's let our calculator do that. We know variable stats will give us the standard deviation. So let's plug those values in and let's do variable stats on them. Okay, so here we go, plugging away. 70, 72, 71, 70, 69, 73, 69, 68, 70, 71, that's the top row. Let's do the bottom, 67, 71, 70, 74, 69, 68, 71, 71, 71, and 72. Okay, and again, if this is my test, I would double check all of those. And if I want the standard deviation, then I'll just go stat, calc, we'll do variable stats. On list 1, it's S that I want, not sigma, because this is a sample. I want that sample standard deviation. So the number I was looking for was 1.725. That's what goes here. Over, and then sigma naught is the sigma tied to H naught, which was 2.5. So that's how I substituted into my formula for the test value. Any questions here? Okay. If you crunch these numbers, I promise you, I'm going to assume you know how to punch that into your calculator, you get 9.0459. So there's step 3. And we were asked to do the classical approach here. Okay. So let me show you the mistake I saw over and over and over and over and over on this one. With classical, I throw alpha in the tail. It's 0.05 and it's going left tail. So how do I find this chi-squared critical value? Well, a lot of you went to your chart and you looked up 0.05 with 19 degrees of freedom. What's the problem with that? Well, class, look at your chi-squared chart. And if you forget the difference between the charts, then just look at what it's telling you. Here's your chi-squared distribution chart. These are areas to the right of a critical value. 0.05 is the area to the left of that critical value. Do you see that? So I didn't want to look up 0.05. 0.05 is if my shading would have been over here on the right tail. The area to the right of this value then would be 0.95. Okay. And 0.95 with 19 degrees of freedom gives me the number 10.117. Now let me stop here one more time before we draw our conclusion. Some of you might be saying, yeah, but Mr. Black, I know sometimes when we were looking at a left tail area, we looked at the same number in the chart. That's true, but that was for a t distribution. And the reason that we can do that for the t distribution is because it's symmetrical. So if I had 0.05 in the left tail of a t distribution here, if I look up 0.05 in the right tail, that's going to give me a positive number. All I got to do is change the sign on that positive number and I get the critical value for the left tail. I can't do that with the chi-square distribution because it's not symmetrical. It's skewed to the right, number 1, and number 2, it's not symmetrical about 0. It starts at 0 over here. Okay, now I need to pause. I need to make sure everybody understands what I just said about finding the critical value here. Okay, then is the test value in the shaded region? Yes, it is. So this was a reject H0 problem. And that's all we were asked to do on that problemo. Okay, so moving on to number 2. By the way, here's a good way to work on your old test. If you don't want to see the answers, take a few sheets of paper, cover up your answer, and then just write. According to a prestigious historical society, in 1999, 7.2% of recent high school graduates believe that the Romans invented mayonnaise. Who cares? By the way, did you know that Miracle Whip, there's one, you can look this up like on Wikipedia, which I know it's Wikipedia, but anyway. Miracle Whip is not mayonnaise, but it's believed that Miracle Whip was invented in Salem. Just thought you might want to know that. Illinois, that is, not Missouri. A classic scholar believes that the percentage has increased since then. He randomly selects 125 recent high school graduates and finds that 17 of them believe in the Roman invention of mayonnaise. Test the researchers' claim at the alpha equals 0.01 level of significance. Tell which type of test you're using. Show all 5 steps of the p-value approach. And on this one, I ask you to give the conclusion. All right. So we're doing a hypothesis test. Question number 1 is, are there 1 or 2 samples? Well, I only see 1 sample here, 125 recent high school graduates. So there's 1 sample. What are we testing about? Well, it says test the researcher's claim. The claim was that the scholar believes the percentage has increased. Percentage is the same as proportion. Proportions can be expressed as a percentage. So using your chart, that puts us with the 1 prop Z test. And most of you said that. Okay, now what's our H naught? Okay, our H naught is that P is equal to what we believed it was. Now listen, P is proportion, so you want to express this as a decimal, not as a percentage here. So 7.2% is 0.072. We believe the proportion of students who believed it was 0.072. We're looking for evidence that what? The scholar believed that the percentage had increased. So we're looking for evidence that P was greater than 0.072. We're testing at 0.01 level of significance. Okay, and let's go get our test value. And we know that the calculator will do all the other hypothesis tests that we did. So it'll do this one. Stat test. 1 prop Z is number 5. I've still got the stuff entered from when I made your key. P naught is the P tied to H naught. It's 0.072. And maybe I don't, because what did we say here? Out of 125 recent high school graduates, 17 of them believe in Roman invention of mayonnaise. It's actually 17 out of 125. And we're doing a right tail. So we got a test value of 2.768. We have a p-value of 0.003. And P is less than alpha. So we reject H naught. So for the conclusion, that means there is significant evidence to show H1, which in this problem means there is sufficient evidence to show that P is greater than 7.2% or 0.072 at alpha equals 0.01. Okay, questions about number 3? How are we doing there, ladies and gentlemen? That was number 2, actually. Always looks easy when a stupid teacher does it, doesn't it? Okay, and finally, number 3. A manufacturer claims that the mean lifetime of its lithium batteries is 1,000 hours. A homeowner selects 25 of these batteries and finds the mean lifetime to be 990 hours with a standard deviation of 80 hours. Test the manufacturer's claim. Use alpha equals 0.05. And we're supposed to use the classical approach. Okay, so how many samples do I have? 1. These 25 batteries are the sample. And what am I testing about? I'm testing the manufacturer's claim, and the manufacturer claims that the mean lifetime is 1,000 hours. So listen, my H naught and my H1 are tied to this 1,000. Some of you tried to tie it to the 990. The 990 is what we got from the sample. And remember, when you make an H naught or an H1, what we're always testing about is the population parameter. We're trying to find something out about the population measure by using the sample. So listen, H naught and H1 is always going to be tied to the population because that's what we're looking for information about. So they believe it's 1,000. We're testing that. So we're going to test to see if it's not 1,000. We're going to do that at 0.05. Okay, and I didn't mention this is one sample about the mean, so that means we're using a t-test. Okay, so that means we're going to get a t naught for a test value, and we can just go to our calculator once again. So find your t-test. It's number 2. We don't have data this time. We've got stats that they gave us. U naught is 1,000. So mu tied to H naught. X bar is the sample mean, that's 990. Standard deviation is 80. And what was my n? We had 25 in our sample. So we're doing a two-tailed test. So we have a test value of negative 0.625. Okay, and here's where a few of you lost your way, because this is a two-tailed test. And so for a few of you, I saw you put 0.05 in each tail. What I'm doing is I'm chopping that 0.05 and splitting it between the two tails. So I did divide that 0.05 by 2 and put 0.025 in each tail. So 0.025 here and 0.025 over here. Okay, and we're going to use 24 degrees of freedom. And now we'll use our chart for the t-distribution to get our critical values. So this time I can just look under 0.025 to get this number and then change the sign on it to get this number over here because the t-distribution is symmetric. So 0.025 in the right tail, 24 degrees of freedom. the number is 2.064. So our numbers are 2.064 and negative 2.064. And the test value is not in the shaded region, so do not reject H naught. Okay, so that's where all this jazz came from on number 3. Okay, that's probably a pretty good stopping point. So the next time we meet, we'll do the last 4 problems on this test, and we'll take any question you've got over anything in the entire class and try to finish getting ready for the final. I do have one last question for you, and it's probably geared toward Lauren or anyone else who wants to answer. So Lauren, you said things seem more normal here. What are your other instructors not doing that would keep it more normal?
So like one of my instructors, he's not doing Zoom at all. He just went straight to Moodle.
Okay.
And I've taken online classes before, but I really like the face-to-face stuff technically, well, over Zoom, you know what I'm saying? And then one of my teachers, probably one of the hardest classes that I've taken, is only doing Zoom once a week. And it's like 45 minutes, and she's not really working out stuff with us, just necessarily telling us what we're doing in Moodle that week. And so, I mean, it's just that, you know, you're actually sticking to the class times and 3 days a week. And
Okay, gotcha. Thank you for your input there. Hey, I hope to see you all Friday. Have a great day. If you run into questions between now and then, shoot me an email and I'll look for those first 2 tests. If I find them, I'll post them. I'll shoot the email back to the person who asked, and I'll also post them on Moodle as well. Okay, have a great day.
Thank you too.
You as well.
Thank you, Mr. Black.
Hey, Mr. Black, I have a question before we go. On number 3 that we just worked out, your value that you're looking at for the reject or not reject, which would be the negative 0.625, the t-value, that's what you're going off of, right?
Well, you got to compare that t-value to your critical values. And the question is always with the classical approach, is the test value, which in this case is that t-value, in the shaded region?
Okay, and since it's not, it's more of in the middle or in the section that's not shaded.
That's right.
So that's why we do not reject it.
Right. For us to have rejected it on this problem, this t-value would have had to have been bigger than 2.064 or smaller than negative 2.064.
Okay.
Does that take care of it for you?
Yep, I think that's all. Well, on number 1 for the same chapter review, there is a portion on it, and I'm not even sure how I got that number, where we were supposed to substitute in the 2.5 for, I got a different number, and you're not even supposed to like come up with that number, so I'm not sure how I got it, but.
Are you talking about, I'm not sure if I heard you correctly, Mackenzie, are you talking about number 1?
Yeah.
Okay. And you're saying you got a different number right here? for your test value?
I got the 19 correct, and then I did the 1.725. I got that part right. But then on the bottom, when you went to put in the 2.5